everyone. So in this video we are going to continue our lesson in chapter 6 chemical equilibrium. Okay, so for weeks 15 we are going to continue for 6.3. So the learning outcomes for this topic is at the end of this lesson you should be able to, the first one, state the Le Chatelier's principle. Okay, B, explain the effect of following factors on a system at equilibrium by using Le Chatelier's principle. First, concentration of reactant species, pressure by changing volume, addition of inert gas at constant volume, addition of inert gas at constant pressure, temperature, and catalyst. So let us look for 6.3. So in Le Chatelier's principle, so we are going to explain about the state, okay, what is state by Le Chatelier's principle, and then we are going to explain the effect of the following factors on equilibrium system, such as concentration, pressure and volume, addition of inert gas at constant volume and pressure, temperature, and catalyst. So, what is Le Chatelier's? Okay, so Le Chatelier's principles is an observation about chemical equilibria of reactions. It states that changes in the temperature, pressure, volume, or concentration of a system will result in predictable and opposing changes in the system in order to achieve a new equilibrium state. So, Le Chatelier's principle can be used in practice to understand the reaction conditions that will favor increased product formation. Okay, so kita gunakan Le Chatelier's principle untuk mencari condition, okay, tindak balas, okay, keadaan tindak balas yang lebih favor the increase in the product formation. This idea was discovered by Henry Louis Le Chatelier. So Le Chatelier's principle states that if a system at equilibrium is disturbed by a change in the temperature, pressure, or a component concentration, the system will shift its equilibrium position so as to counteract the effect of the disturbance. So, this is the Henry Louis Le Chatelier, 1850 until 1936, a French chemist. Right, so the three common disturbance, okay, tiga gangguan yang biasa kita lihat di dalam prinsip Le Chatelier. The first one is the change in concentration, okay, perubahan di dalam kepekatan. The change in pressure, which caused by change in volume. And then the change in temperature, okay, perubahan suhu. Dan kita tengok the position of equilibrium. So the position of equilibrium refers to the relative amounts of products and reactants in an equilibrium mixture. When equilibrium position shifts to the left, it means the concentration of reactants increases. Okay, so bila equilibrium position bergerak ke sebelah kiri, dia bermaksud tindak balas akan reactant akan meningkat, because at the left hand side is reactants. When the equilibrium position to the right shift to the right, okay, bergerak ke sebelah kanan, it means the concentration of products increases, okay, because the left hand side is reactant and at the right hand side is product. So Le Chatelier's principle, if a change is made to a system at dynamic equilibrium, the position of equilibrium moves to minimize this change. Jadi, bila kita ganggu sesuatu keseimbangan dinamik dalam sistem, so the position of equilibrium, okay, kedudukan keseimbangan akan bergerak untuk minimize, mengurangkan perubahan ini. So, the principle is used to predict changes to the position of equilibrium when there are changes in temperature, pressure, or concentration. So, Le Chatelier's principle, we can use the seesaw analogy. Kita gunakan analogi jongkang-jongkit. So, a chemical reaction at equilibrium is like a seesaw. Okay, dia seperti jongkang-jongkit. So, when it is at equilibrium, the reactants and product is equal. So, recall that at equilibrium, a system is in balance. Okay, pada keseimbangan, sistem adalah seimbang, balance. So the rate forward and the rate reverse is equal and the concentrations of reactant and products are constant. So if we add more reactant, jadi kalau kita letakkan lebih banyak reactant di sebelah kiri di sini, okay, add more reactant, so dia akan unbalanced. Okay, the reaction will become unbalanced. Okay, so how to balance? To restore the equilibrium, the reaction will shift to the right. Okay, dia akan bergerak ke sebelah mana? Ke sebelah kanan. Okay, to make more products and bring the seesaw back to balance. So it's very easy for us to understand this analogy. So dia seimbang semula. Okay, alright. So the changes in concentration. Okay, perubahan di dalam kepekatan. So let's consider this equation. Okay, so the equation is between nitrogen gas and hydrogen gas produced to ammonia NH3. So when we add more product, okay, bila kita masukkan lebih banyak produk, dia akan condong ke sebelah kanan. Kalau mengikut analogi seesaw, okay, so dia akan condong ke sebelah kanan. Okay, alright. Bila kita masukkan lebih banyak ammonia di sini. Jadi macam mana cara dia nak reduce the disturbance? Dia akan shift to the left. So add more ammonia to the system, the concentration of product will increase. Thus, equilibrium position shift to the left to reduce the increased concentration of product. Okay? Alright, so shift to the left and it will produce more nitrogen and hydrogen if you add more ammonia. Okay. Okay, next let us consider this equation. So we have nitrogen and hydrogen will produce ammonia. So if we remove some reactants, remove reactant meaning that we remove nitrogen and hydrogen, so the system is not at equilibrium. Okay, so bila kita remove hydrogen and nitrogen, so our seesaw dia akan unbalanced. Okay, jadi bila dia unbalanced, okay, now macam mana cara kita nak remove? Okay, kita nak increase, jadi kita akan shift to the left. So kita tengok, when we remove nitrogen or hydrogen from the system, the concentration of reactant will decrease. Jadi concentration nitrogen and hydrogen akan decrease. So equilibrium position shift to the left to form more reactants. Jadi dia akan menghasilkan nitrogen ataupun hydrogen. Okay. Okay, next the changes in concentration. Okay, when we remove some products. So bila kita remove some products, okay, remove ammonia from the system. So the concentration of product ammonia will decrease. Okay, jadi bila dia akan decrease, equilibrium position dia akan shift to the right to produce more ammonia. Sebab apa? Sebab kita dah keluarkan NH3 daripada sistem. So they can shift to the right. So the change in concentration, okay, the application in our daily life. So for example, we have oxygen and the lungs, okay, hemoglobin and oxygen. So hemoglobin plus oxygen will produce HbO2, okay, and then they can remove and produce Hb plus oxygen. So hemoglobin is a red blood cell protein used to transport oxygen from the lung to the body tissue. Okay, so lung, okay, our lung is oxygen, concentration of oxygen is high. Jadi bila concentration of oxygen is high, the forward reaction akan favor. So the hemoglobin in the blood binds with oxygen. Okay, so the tissue, okay, tissue is concentration of oxygen is low. Jadi bila dia rendah, the reverse reaction favor, thus hemoglobin will release oxygen to the cell. Okay, so this is the application di dalam our daily life. Alright, next, the changes in pressure or volume. So based on the ideal gas equation, PV is equal to nRT. Okay, so the pressure is directly proportional to the number of mole of a gas molecule. Jadi P is directly proportional to N. Okay, so bila P increase, number of mole also increase. So stoichiometric coefficient of chemical equation represent the total number of mole of gas molecules on each side of the equation. Therefore, a system can counteract the changes in pressure by shifting the equilibrium position towards the sides with fewer or more number moles of gas. in order to decrease or increase the pressure of the system. So pressure is directly proportional to N. Okay, bila P increase, number of mole also increase. Okay, so di sini kita tengok at the left hand side kita ada 1 mole of N2O4, and at the right hand side we have 2 mole of NO2 gas. So left we have 1 mole, right we have 2 moles. So for this equation, left we have 1 plus 3, which is 4 mole. Okay, and then right kita ada 2 mole. Okay, number 3, 2H2O at the left hand side, 2 moles. And then at the right hand side is 2 plus 1 is 3 mole. And then untuk 4, we have 1 mole of NH4Cl, but NH4Cl di sini adalah dalam phase of solid. Okay, then this one is ammonia in the mole of gas, in the form of gas, 1 mole, and then HCl 1 mole. Jadi 1 plus 1 is 2 mole at the right hand side, then 0 mole of gas at the left hand side. Then H2O liquid plus SO3 gas produce H2SO4. So H2SO4 is aqueous 1 mole, and then gas 1 mole, liquid 1 mole. Jadi liquid kita tidak ambil kira, jadi kita cuma ambil SO3 gas. Okay, 0 plus 1 mole. Okay, aqueous juga tak ada pressure, jadi aqueous tak ada bilangan mole gas. Okay, alright, so 0. Alright, so the change in pressure and volume, consider this general equation. 3B produce C, meaning that 3 mole of B, okay, will produce C. Okay, dissociate menghasilkan C, then C will left shift to the left, okay, reverse akan hasilkan 3B. So at the left hand side is 3 mole, the right hand side is 1 mole. So increase pressure. Jadi bila kita increase pressure, meaning that, okay, increase pressure, the volume akan menjadi lebih kecil. Jadi bila volume lebih kecil, dia akan favor ke bilangan mole yang sedikit. Okay, equilibrium position shift to the side with lower mole of gas. Sebab, okay, because when pressure increase, volume will decrease. The volume decrease meaning that bekas tu container is smaller. So in order to reduce the pressure of the system, okay, that can shift to the side with lower mole of gas. So bila kita decrease the pressure, okay, when we decrease the pressure, meaning that volume will increase. Bekas menjadi lebih besar. So that can shift to the, okay, side with higher mole of gas. So kalau untuk sistem di atas ni, dia akan shift to the left. Right. So kita ada N2 plus hydrogen produce 2 ammonia. So 1 mole plus 3, ke sebelah kiri kita ada 4, sebelah kanan kita ada 2 moles. So, okay, bila kita increase, okay, sekarang the system is at equilibrium. So bila kita turunkan ke bawah piston, so the system will not at equilibrium. So dia akan shift kepada mole yang sedikit. Jadi mole yang sedikit di sebelah mana? At the right hand side. So dia akan increase the pressure through the decrease in volume. Okay, so dia akan shift to the right. Jadi bila dia shift to the right, equilibrium is re-established. Next, changes in pressure and volume. What happens to the system if volume of container decreases? Okay, bila volume decrease, right? So kalau volume decrease, at the left hand side we have 2 mole. Okay, left hand side we have 2 mole, right hand side we have 1 mole. Jadi container decrease, okay, volume of container decrease, meaning that dia akan shift kepada bilangan mole yang sedikit, which is shift to the right. When volume decrease, pressure will increase. So reaction move forward because number of mole of product is smaller than that of reactant. Okay, jadi dia akan shift kepada bahagian yang sedikit lah. Okay, dia akan shift to the right. So equilibrium position shift to the right side with lower moles of gas in order to reduce the pressure. So the next one, what happened to the system if volume of container increases? Jadi kalau volume increase, okay, so at the left hand side we have 1 plus 1, we have 2 mole. The left hand side we have 2 mole. The right hand side we have 1 mole. Okay, so when volume increase, dia akan shift kepada sites yang lebih banyak mole, which is okay 2 mole in 1 mole. When volume increase, pressure of the system is decreased. Reaction moves to backward. Okay, dia akan reverse because number of moles of reactant is higher than that of product. Jadi reactant lebih banyak. Reactant is more than product. So the equilibrium position shift to the left. Okay, side with higher mole of gas in order to increase the pressure. Okay, sebab dia nak increase the pressure di sini. Okay, so addition of inert gas. Addition of inert gas dia ada dua condition. Yang pertama sekali at constant pressure and constant volume. Okay, kalau kita masukkan at constant pressure, okay, at constant pressure volume will change. Jadi bila volume will change, partial pressure of each gas in the system decreases. Thus equilibrium dia akan shift to the side with higher mole. Okay, bila constant pressure, volume will increase. So at constant volume, okay, bila volume tidak berubah, so partial pressure of each gas in the system remain unchanged, does not affect on equilibrium position. Why? Okay, right. So this is because adding the inert gas to the system will increases the total pressure of the container. Okay, bila kita adding inert gas to the system, dia akan increase the total pressure of the container. In order to keep pressure constant, okay, the volume of the container has to expand. This causes the partial pressures for each gas in the system to drop. Okay, dia akan menyebabkan partial pressure bagi setiap gas dalam sistem akan jatuh. So equilibrium position will shift towards the side with higher mole of gas in order to increase the pressure of the system. Jadi dia akan shift to the side with higher mole of gas in order to increase the pressure of the system. Okay, so now the system, the left hand side kita ada 1 mole, right hand side we have 2 moles. So the pressure of mixture of nitrogen and N2O4, partial pressure of NO2 is 6 atm, partial pressure of N2O4 is 4 atm. So the total is 4 plus 6 is 10 atm. So before addition of the helium, P total is equal to 10 atm. Okay, bila kita dah masukkan helium. Helium is ada inert gas. Okay, so mixture of helium, hydrogen, NO2 and N2O4. So partial pressure of NO2 dia akan jadi 5.5 and partial pressure of N2O4 will becomes 3.5 and partial pressure of helium is 1 atm. So total tidak berubah. Okay, P total dia masih lagi berapa? 10 atm. Thus, after addition of helium, P total is still 10 atm. So, volume will expand to keep the pressure constant. Okay, jadi volume akan expand. So, kalau volume expand, P total remain constant. So, partial pressure of NO2 and N2O4 in the system decreases after the addition of helium. Okay, so partial pressure for the system, okay, equilibrium position, dia akan shift to the right with side with higher moles to increase the pressure, meaning that it will shift to the right. Okay, bilangan mole yang lebih banyak. Okay, what happened to the system if helium is added to this reaction at constant pressure? So kita ada PCl3 plus Cl2. Okay, 1 plus 1 is 2. Right hand side is PCl5, 1 mole. When inert gas is added, okay, bila kita masukkan gas lengai, the partial pressure of each gas in the system decreases. Jadi, at the left hand side we have 2 moles, right hand side we have 1 mole. So reaction moves backward. Okay, because number of mole of reactant is higher than that of product. Sebab sebelah kiri kita ada 2 mole, kanan kita ada 1 mole. So equilibrium position, we shift to the left, okay, dia akan bergerak ke arah bilangan mole yang lebih tinggi, okay, in order to increase the pressure of the system. Okay, shift to the left. Next, what happened to the system if argon is added? to this reaction at constant pressure. So kalau constant pressure, okay, kita boleh tengok volume. So in term of volume, so this one is 2 plus 1 is 3 mole. Then this one is 2 mole. Okay, so when inert gas is added, the partial pressure of each gas in the system will decrease. Okay, jadi bila dia decrease, reaction dia akan move forward. Okay, reaction will move forward because number of moles of product is higher than that of reactant. Jadi dia akan pergi ke arah 3 mol. Okay, 3 mol sebelah mana? Sebelah kanan. So equilibrium position shift to the right, okay, which is side with higher mole of gas in order to increase the pressure of the system. Next, addition of inert gas at constant volume. So addition of inert gas causes the total pressure in the container to increase. However, the partial pressure for each gas in the system remains the same, therefore the equilibrium position does not change. Okay, kalau inert gas at constant volume. So another example. So the system is N2O4 gas produce 2NO2 gas. So mixture of NO2 plus N2O4 is 10 atm before addition. Okay. After addition, volume will remain constant, but the total pressure dia akan increase. Okay. Volume remain constant and pressure in container increase. Jadi dia akan jadi berapa? 11 atm. So dia akan shift. Okay. PNO2 and PN2O4 system remain unchanged after addition of helium. Okay, because the system is at equilibrium. So no change in equilibrium position. Okay, alright. So what happened to the system if helium is added to this reaction at constant volume? Okay, so again, dia sama macam konsep yang tadi, walaupun kita masukkan helium gas. Okay, the concept is very simple. You just memorize. They can shift to the left or shift to the right. Okay, so kalau constant volume, meaning that no change. When inert gas is added, the partial pressures for each gas in the system remains unchanged. So no effect on equilibrium position. So now we continue in the change in temperature. So the effect of temperature on equilibrium depends on the type of reactions, which is kita ada dua, exothermic and endothermic reaction. So temperature is the only factor that affects by the value of K. So endothermic reaction. An endothermic reaction is a reaction that absorbs heat to form products. For example, we have nitrogen and oxygen will produce 2NO. And delta H is positive. Positive meaning that heat is absorbed. So heat, okay, kita letak di bahagian reactant. Positive sign indicates that the forward reaction will absorb heat. Jadi kalau dia nak jadi ke hadapan, dia akan absorb heat. So if forward reaction absorb heat, then the reverse reaction will release heat. Okay. Endothermic reaction. Heat is needed for the reaction to occur. Therefore, heat is considered as one of the reactant. So the chemical equation can be rewritten as follows. So we add heat at the reactant side. So if we add heat at the reactant side, meaning that heat as a reactant in the reaction of endothermic. Okay, so increasing the temperature. So when we increase the temperature, okay, meaning that we add heat to the system. So bila kita add heat to the system, it will shift to the right. Okay, so heat is added to the system, meaning that we add more reactant to the system. The reaction will move forward. Forward reaction absorb heat. Okay, so as to reduce the added heat. So equilibrium position will shift to the right bila kita add heat. Okay, when increase the temperature. Decreasing the temperature, okay, meaning that we remove some heat. Bila kita remove heat, meaning that reactant side is left in reactant. So heat is removed from the system, so the equilibrium position will shift to the left and to replace the heat loss, because since the reverse reaction is exothermic. Next, we look into the exothermic reaction. Exothermic reaction is a reaction that releases heat to form products. For example, PCl3 plus Cl2 produce PCl5, meaning for this reaction, okay, it will release heat because the sign is negative. Negative indicates that for the forward reaction release heat. If forward reaction release heat, then the reverse reaction will absorb heat. Heat is produced when the reaction occurs. Okay, haba dibebaskan bila berlaku tindak balas. Therefore, heat is considered as one of the product. So the chemical equation can be rewritten as follows. PCl3 plus Cl2 will produce PCl5 plus heat. Delta H is negative 111 kJ, meaning that heat we put at the right hand side, at the product side. Okay, increasing the temperature. Okay, increase the temperature in the exothermic reaction, meaning that we add more heat to the reaction. So bila kita masukkan heat, dia akan shift to the left. Okay, equilibrium position shift to the left to reduce the added heat. This is because the reverse reaction will absorb heat, which is endothermic. So when we decrease the temperature, okay, kalau kita keluarkan haba, meaning that the reactant, okay, will shift to the right to produce more heat. Heat is removed from the system. The reaction will move forward. Forward reaction release heat so as to replace the heat lost. So the equilibrium position shift to the right. So addition of catalysts. Addition of catalysts. Catalysts are the substances that increase the rate of chemical reaction but are not used in the reaction. Dia tidak digunakan di dalam tindak balas. The function of catalyst is to increase the rate of reaction by providing the alternative pathway with lower activation energy. So the rate of forward reaction and reverse increases. So the catalyst allow a system to reach equilibrium faster but does not shift to the position of an equilibrium system. Okay, energy profile diagram. This is the energy profile diagram. So you will learn to draw the energy profile diagram in the second semester, actually in chapter 1 reaction kinetic, which is EA is the minimum energy required to initiate a chemical reaction. So this is the reaction pathway without catalyst. Jadi kalau reaction without a catalyst is higher, okay, bila kita put a catalyst in the reaction, it will have a lower activation energy. Okay, because the product form is the same. Okay, product adalah sama. So this one is EA prime, this is EA. So reaction pathway with catalyst will have a lower activation energy and a shorter reaction pathway which reach equilibrium faster. As a conclusion, okay, so the change in concentration will shift the equilibrium. Yes. The change in equilibrium constant, the value of K, no. So pressure will shift the equilibrium, yes, but value of K does not change. Okay, for volume, okay, will shift the equilibrium, yes, it will shift the equilibrium, and the change in constant value, no. Temperature, yes, shift the equilibrium, and it will change the equilibrium constant, the value of K. Okay, the only factor. And for catalyst, okay, catalyst does not change the shift of equilibrium, and then the change in equilibrium constant also does not change. Okay, alright, so that's all for this part. Thank you, class.